4 presents us with a few very interesting questions. Really lovely. Still playing with the cosine rule based on page 333, but this is question 5. It says a clock has a minute hand that is 8 centimeters long and an hour hand that is 6 centimeters long. Right, so we've got 6 and 8. Alright, good. Calculate the distance between the tips of the hands at 2 o'clock. Right, let's try and do this. Well, 2 o'clock. O'clock means the big hand is going to point towards the 12, and so that's going to be 8 centimeters long. And the little hand, let's make it look like that, is going to be 6 centimeters long. And what we've got ourselves is a little triangle, like so, and I've got to find the distance between the tips of the hands. Looks great, doesn't it? Well, not really, because we have to work out the angle between the 12, which is there, and the 2, which is there. Now, between 12 and 2, we have 2 hours. Now, 2 hours is going to be 2/12ths of a rotation, because we're going from 12 all the way around, 6, 7, 8, 9, 10, 11, 12, and back again. We've got 12 sections, 12 hours, that correspond to 360 degrees. So let's just write that quickly. So 12 hours is equivalent to 360 degrees. So 1 hour is equivalent to 360 degrees divided by 12. In other words, 30 degrees. That goes in there 3 times, doesn't it? Yeah. So 2 hours. Now it's from 12 to 1 to 2. We've spanned an angle of 2 lots of 30. Yeah, 60 degrees. So essentially, what I've got is a triangle with the long hand 8, the short hand 6, and the angle 60 degrees. And I've got myself a cosine rule problem. Okay, I've got the angle. I want to work out the length opposite, which I want to call x, and I've got an 8 and a 6. So here I go. In terms of problems and solving problems, it's a useless problem. It's barely functional mathematics, but it's interesting because there's an application of the cosine rule there. So look, I want to work out the mystery length x and not an angle, so life is a lot easier that way around. So let's just do it underneath here then. So x squared equals the other two sides squared, so that should be squared, plus 6 squared minus 2 lots of 8 times 6 times, that's meant to be an 8, times the cosine of the angle, which is given to us as 60. Now we can do that in one step, because we're allowed to do that. Well, 8 8s are 64, plus 6 6s 36, minus 2 times 8 times 6, and hit the cos button, cos 60. So all that's written on the screen there, all that has been put into the calculator, that's a 6, and equals. Right, all that has come to 52. So therefore, x is going to be the square root of 52, and the square root of 52 is going to be something, I'm sure. Yes, it is something. It is 7.2 centimeters in length. And there it is. It's a lovely little question, not particularly useful. I mean, you have to sit there thinking, I wonder what the length is between that tip and that tip. Why would you want to do that? It's crazy. But anyway, it's interesting, and I think I'll do the next one sort of down here somewhere out of the way. Hopefully it will fit. Similar sort of thing, but probably tougher. Same thing, but we're playing with 430. Right, so 430. So imagine that's the center. 430 is a big hand straight down. That's 8 centimeters. And 4 is going to be about here somewhere, say, and that's 6 centimeters. So that's, if you like, the position of the 6, and that's the position between 4 and 5. So I want to call that 4 stroke 5, say, in my brain. So what have I got here? From 430, just do a little quick join there, I've got to do that length there. From 430 to 630, I've got 1.5 hours. So let's just do it in blue. Therefore, 1.5 times 30 degrees equals 45 degrees. Okay, work it out. If you can't see it, just draw yourself a quick little clock and go 6, 5, 4. So that's 2 lots of 30 degrees, and at 4:30 we're looking at the distance their half an hour's worth and another hour, so it's 1.5 hours times 30 degrees. Alright, so 1.5 times 30 degrees. Remember, each hour is 30 degrees, we worked out earlier. So we're looking at 45 degrees there. So if you put it there in black, it stands out a lot better. I don't learn well, do I? So I've got essentially a triangle subtending an angle of 45 degrees at the point there, and producing lengths of 8 and 6. So I've got an 8 and a 6 and a 45 between it. So it's the same rigmarole then. Let's find mystery length x then. So x squared equals the other two squared, the same thing. So 8, it's the same, you know, clock, isn't it? 8 plus 6 squared minus 2 lots of 8 times 6 times the cosine of 45 degrees. Let's just punch it into the machine. So I've got 64 plus 36. Take away 2 lots of 48, that's 8 sixes. 2 times 48 times the cosine of 45. We now have 32.11, whatever it is, 32.1177. So x on its own is going to be the square root of 32.1177. Again, I'm quite happy to write all this in, so I let my calculator do the talking. Root it, bam, 5.67. So let's go one decimal place, 5.7 centimeters, and that's it. Lovely, tidy little question. I'm going to stop that one there because the other two are a challenge. They're very, very busy indeed. So that was worth its own little video, okay? Lovely little application, barely functional though. It's not useful knowledge to go around working out the distance between the tip of the big hand and the tip of the little hand. You know, it's what's all that about? Anyway, but it's grade A, and the next problem solving ones, I'll do questions 6 and 7. They're not been given a grade, they're probably beyond grade A, therefore A star, because we're applying this to tricky situations. Alright, so that's question 5 done on page 334, and I'll see you soon for the other two.